All right, for homework number 6, the first thing we have to do is match the function with one of the graphs to the right here. And so when you're trying to do this, one thing I'm looking at will be the horizontal asymptote. And then some of these have the same horizontal asymptote. So you can also start plugging in points for x and see what points need to be on the graph. So for number 1, there should be a horizontal asymptote of y equals 2, but there are several of those where that exists. So then the next thing to check is when I plug in 0 for x, I would get 0 for y. So that rules out A. It can't be C because f of x is an even function, so it's going to have y-axis symmetry. All right, so it can't be C or D. So it looks like it's going to have to be F because that has a 0, 0 point. It's got y-axis symmetry, and it's got a horizontal asymptote at 2. So F. All right, and then for number 2, remember when we look at horizontal asymptotes, the plus 2 doesn't matter at infinity. So the limit as x approaches infinity of 2x over square root of x squared is y equals 2. Now this one, though, will be different left and right. This is an odd function because if I plug in negative x, I would get negative 2x over square root of x squared plus 2. So it's an odd function, which means that this is going to be y equals 2 on the right. But then as you plug in negative infinity, that limit's going to be negative on top divided by a huge number. So you'll be approaching y equals, negative on top divided by the square root of x squared, which will stay positive. So you'll be approaching y equals negative 2 to the left. So the only graph that has 2 different horizontal asymptotes is C. So this one has to be C. All right, let's see. Number 3, there is a horizontal asymptote at 0, passing through the point 0, 0. So let's look at that. So here's graph B fits that, graph D fits that. So we're deciding between B and D. And the big difference is what do you get when you plug in 1? So I'm going to plug in 1 and see if I get a fraction or something bigger than 1. So if I plug 1 into this, I get 1 over 1 squared plus 2. So that's going to fit graph D. Okay, number 4. The horizontal asymptote here is 2 plus 0 because of this bottom heavy function, so y equals 2. If I plug in 0, I get 2 plus 0, I get 2. So let's check right now. We have a point that goes through 0, 2, and a horizontal asymptote. So A fits that description and nothing else. So I'm going to stop analyzing there and just go with A. All right, 4 sine divided by x squared plus 1. So remember, 4 sine will stay between 4 times negative 1 or 4 times 1, and then you'll end up dividing by infinity. So you're going to have a horizontal asymptote of 0 for this one. And then my only choice there is B because we're down to B and E. So B. That means that number 6 has to be E. And if we just kind of verify, it should have a horizontal asymptote at 2. And if I plug in 0, I get 5. So yeah, that's fitting with graph E. All right, now I'm not going to redo this one, but we were supposed to use this function, complete the table to estimate the limit as x approaches infinity. And this pretty quickly was clear that you're going to get 3. So I typed in 10 to the 0, which is 1, 10, 10 to the 6th. My calculator said it was exactly negative 3, which is not quite true, but that's as far as the calculator can, as accurate as the calculator can calculate. And if you check the graph, you should also see that there is a horizontal asymptote on the right at negative 3. All right, these are limits at infinity. So remember, you're thinking horizontal asymptote rules for a lot of these. So this is a tie. This answer is 2/3. For the next one, I'm plugging in negative infinity. So if I do that, let's do it down here. 1/2 times negative infinity is negative infinity. Minus 4 over negative infinity squared is just an infinity, whatever. So this is 0. Negative infinity minus 0 is still just negative infinity. So this limit does not exist, but we're saying in which direction is it bounded. For the next one, remember when you have multiple terms like this, we kind of ignore this minus x. It's going to be really insignificant compared to the x squared. So you're kind of just looking at, okay, how does x over square root of x squared simplify in the long run as we approach negative infinity? So it simplifies to x over absolute value x. And so that matters because if we're headed to negative infinity, we're going to be getting a negative x over a positive x. So that's going to divide out to -1. And you can confirm all of these by graphing, but it's just important to know that we are expected to do these without a graphing calculator. So we want to be able to think through it numerically, but sometimes it helps to have some of this in your head graphically as well. Okay, be careful of 37. We have that sign of the limit of sine x over x memorized, but that is the limit as x approaches 0, not infinity. So as we're approaching infinity, this is not necessarily equal to 1. This is just saying, okay, the sine of 2x will fluctuate between -1 and 1. But then the x in the denominator, as I plug in infinity, is just going to get really large. It's going to be infinity. So 1 over infinity or -1 over infinity or any decimal in between there is still going to come out to 0. For 38, I don't want to plug in infinity right now because that's kind of confusing, but I do want to simplify this. Remember that we called this the Hart method in pre-calc, that you can divide each term by this monomial. So really we're looking at the limit as x approaches infinity of x over x, which is 1, minus cosine x over x. And now it's a problem kind of similar to 37, where the limit as x approaches infinity of 1 is 1. Cosine is going to stay between plus or minus 1. And then x is just going to get really large. So this term is 0. And then 1 minus 0 is 1. All right, now this next problem, you will not be expected to make substitutions like this that I know of on your own. So I'm very heavily relying on this hint that I would not have probably thought of for myself. So this says, find the limit as x approaches infinity of x sine of 1 over x. And it's like, okay, well, that's infinity times the sine of 0. Infinity times 0 is indeterminate. We will talk about that, but like it's not guaranteed to be 0, basically, is what this answer is. So they're telling us, okay, let x equal 1 over t. So let's replace all of the x's with a 1 over t. And instead of looking at the limit as x approaches infinity, we're going to look at the limit as t approaches 0 from the positive. So I'm just going to follow the directions. Find the limit as t approaches 0 from the positive. Instead of x, it's 1 over t. Times the sine of, instead of 1 over x, it's 1 over 1 over t. And let's clean that up because that's ugly to look at and hard to work with. 1 over t, first of all, that t can just be down here. Sine of 1 over t is just the sine of t. Now, rewriting it like this is helpful because this is the limit I just referenced previously. Remember, back here I said, careful, this is not the limit that we memorized, but this one is. The limit as the variable approaches 0 of sine t over t, we know that that limit is equal to 1. So our limit here is also equal to 1. And why does this work? If x is approaching infinity and we change this to t approaching 0 from the right, remember 1 over 0 from the right is infinity. You're going to keep getting a large number as you get closer and closer to 0. Okay, so yeah, so like I said, if we would have just done direct substitution, infinity times 0, you might think is 0. or maybe infinity, I guess, but actually this one came out to 1. So kind of tricky. We'll talk more about these indeterminate forms in the future. And this last one I forgot to erase, so I'm just going to talk through it here. This was like in a little writing section. So if f is continuous such that the limit as x approaches infinity of f of x equals 5, so we have a horizontal asymptote on the right that we know about of being 5, find the possible limit as x approaches negative infinity for each specified condition. So for part A, the graph is symmetric with respect to the y-axis. So that's also known as f being an even function. We should know that from our pre-calc days. And so an even y-axis symmetry looks something like this. So if the graph is approaching 5 on the right, then it's got to be doing the same thing on the left. So that limit as x approaches negative infinity is 5. And just to be fancy, I tossed in the fact that even functions have this property. That's another way to think about it. F of negative infinity should equal f of infinity, or those limits at least when we do direct substitution. And then similarly for the origin symmetry looks like this. And so if the graph is going toward positive 5 on the right, it's got to be doing the exact opposite of that on the left. So the limit at negative infinity is negative 5. I also threw in the odd definition of an odd function is that f of negative x should equal negative f of x. So f of negative infinity, when I direct substitute, should be negative f of infinity. All right, that finishes up this homework assignment. Please come into office hours if you have questions on any of this.